So today we're going to continue our conversation about algorithms. The first set of algorithms we're going to look at are the sorting algorithms. These are definitely on the AP exam. The code is on the AP exam in that you have to be able to recognize the code for each of these algorithms. So sorting is a fundamental thing in computer science. You have to be able to sort out lists. Why? Because it makes searching easier. Really, that is the major reason to sort stuff. Yeah, it's nice to have things in alphabetical order or whatever, but the main reason to sort stuff is so you can find information. Indexing information is very, very critical and important as we go into database management and all that type of fun stuff. Data is the big push right now. So how do we go ahead and do some sorts? Well, there's a couple basic ones. The first one, the BubbleSort, is not on the AP exam, but it is kind of an entryway into sorting because it is the easiest sort to understand, and it kind of leads into some of the fundamentals of some of the other sorts that are being done. So you don't have to learn the code for this, but we do have to know the algorithm for this. So I'm going to walk you through what the sort looks like, and then I will have a little demonstration for you by some Hungarian dancers. So first you have a list. And essentially what it does is it compares two elements at a time. So first it compares the 5 and the 1. Well, that's calibrated off. Compares the 5 and the 1. And if the 1 is less than the 5, then it swaps it. Then it moves on to the next spot, the 5 and the 4. If the 4 is less than the 5, then it swaps it. Then it compares the 5 and the 2. If the 2 is less than the 5, then it swaps it. And finally, it compares the 5 and the 8. If the 5 is less than the 8, then it would swap it. But, excuse me, if the 8 is less than the 5, then it would swap it, but it's not. The 8 is not less than 5, so it doesn't swap it. So it kind of acts like a bubble floating down the list, taking two item pairs at a time. Here's another example. Or is this the same example? Oh yeah, second pass. So we got to go through the loop again. 1, 4, 2, 5, 8, because it's not quite in order yet. So we start all the way back at the beginning. 1 and 4 are fine, but 4 and 2 are not, so they get swapped. Then we look at the order and look at the 4 and 5, they're fine. Then we look at the order and the 5 and the 8 are fine. Technically, it's sorted, right? But the computer doesn't know that. The computer has no idea that the list 1, 2, 4, 5, 8 is currently sorted. So it goes ahead and so the algorithm will go through the entire list again for the third time, and if it doesn't have to swap anything, it knows it's done. That's its test to determine if it has completed the sorting. So it continuously goes through floating that bubble up and down the list until no swaps need to be made. So our third pass, we go all the way through and nothing happens. But it does have to go all the way through just to realize that no swaps have been made. The idea of that flag comes up again. If a swap occurs, then we set a flag that says, yes, a swap occurred. So if we go through the list and no swap has occurred, then that flag is not set, and we know we're done. So there's that idea of flags we talked about before being very useful. This is kind of what it looks like if we do it with a Cartesian coordinate system. So each x and y point indicate the value y is sorted at index x. So the y is the values, the x is the index. Then the list would be sorted by BubbleSort. So every pixel value gets sorted. Notice we get the bigger values that could sort it first, and it works its way down the list. So that's just one visualization, but a more entertaining one. So this is a little video of some Hungarian dancers. I would like you to watch this. You can find it in Blackboard under the BubbleSort tab. So go ahead and hit play on that. I'm going to pause the video. So hopefully you finished watching the Hungarian BubbleSort video, and you can see that they went through repeatedly swapping over and over again. Yeah, that was tedious. This is the reason why we don't use BubbleSort, because BubbleSort is really tedious. However, it works. It does sort out a list very efficiently. Suppose, let's take a really extreme example. Suppose I had a whole bunch of people in line for the Statue of Liberty. And somebody said, all right, here's what we're going to do. Statue of Liberty line's closed. But for fun, since we're all stuck in this line. Yeah, let's dance. Now, let's sort this line. Let's sort this line alphabetically in place. So in other words, like, you know, we want to take the entire line through the entire Statue of Liberty, you know, all the way up the winding staircase and get the entire line to sort. So we can sort using BubbleSort pretty easily because you're only swapping two people in a set of stairs. That would be pretty easy to do. And you can imagine that being very self-sustaining. You know, if everybody knows that you're just sorting, what's your name, spin it, what's your name, spin it. And then by the time you're done and nobody switches position, then you know you've completed the sort. Now to make it work a little bit better, instead of going down the list and then down the list again, always starting from the top, it might make sense for us to go down the list and then back up the other direction. Really doesn't make that much of a difference in terms of which direction you go in the list with the BubbleSort. It would change. It wouldn't technically be a true BubbleSort anymore, but it would still effectively work on a set of stairs. And you could bounce back and forth of that until all the sorts are completed. But you notice you have to go through the list a lot. So what kind of code do you think we would need to run this? So we're going to think about what code is making this work. Clearly we're using some type of looping structure, but what kind of looping structure would we need? So I want you to pause the video and think about that for a minute. We're going to talk about it. So let's talk about what you guys came up with. All right. If you look at, I was talking to one of the groups and I was listening a little bit, and from what I was hearing, we need two loops. One to control whether or not we're finished. You know, one to let us know that we have done no swaps. Another one to go through the list. Because we repeatedly go through the list. And if you think about that structure, you need a loop to go through the list. And then since you repeat going through the list, that implies two loops. One on the outside, one on the inside. So if we look at like a pseudocode implementation of this, we're going to repeat. And if swap, we're going to repeat if swap is false. Now this is weird because this is not Java, right? So there's this idea of pseudocode where you kind of just write out in words how you would do this, not necessarily worrying about the syntax of the language that you're working in. So this is just one example of pseudocode. You don't have to memorize any commands here. This is really your own words of saying it. So when I was talking to the group over there, they said, well, we would need some type of while loop in the front, and we would keep looping until we're not done, until we're done. And then on the inside, we have to have some other type of for loop that would go through the list repeatedly. And that's essentially what this is saying here. repeat until swapped equals false. And we have a little for loop. We got some comments here. If this pair is out of order, if ai minus 1 is greater than ai sub 0, then swap them. And this is how they're calling. They got some type of command here called swap. There's no swap command. They just said, we're going to make it called swap because we haven't figured out how we're going to handle that yet. So if it gets swapped, then we set the flag to be true. And if, and for, and then until we have not swapped. So we keep going until we have not swapped. So this is not the best end procedure. This is not the best pseudocode for you guys because you don't recognize a lot of it. I would use words. Write it out in the English language as to how you would go ahead and do this. So, like I said, BubbleSort, we're not going to worry too much about, so we're not going to look at code for it. It's not on the AP exam. We're not going to do a deep dive onto it. We're going to move on to the next sort. This sort is called the insertion sort. This works a little bit differently. It builds the final list one item at a time by inserting each value into its proper spot in the list. So it's going through and one at a time taking values and inserting them into the proper spot in the list. However, it's not doing a separate list. It's not saying, okay, here's my full list, and then we're going to take the first value and put it into the new list. And then I'm going to take the second value and put it into the right spot in the new list. It's not a separate list. It's actually the same list. They're just putting it at the front. So they're effectively treating the list itself as two lists. A front sorted half and the rest of the list not sorted. So in order to help you understand that, we're going to go back to our Hungarian dancers. So our Hungarian dancers, there's a video for the insertion sort. I want you to pause the video and take a look at the Hungarian insertion sort dancers. So what is our looping structure? The question is, in order to make this happen, how do we do our insertion sort? What kind of looping structure we're going to need? So pause the video, think about it. So when we're looking at our insertion sort, we need a looping structure to control going through the entire list one element at a time and telling it to dance up the list. So the outside loop is a for loop because the list is a set size. The inside loop is some type of while loop because the character does not necessarily dance through the entire list. Some of them may not go very far at all. Some of them may not move. They could just happen to be in the right spot. So on the outside we have a for loop. On the inside we have a while loop. So when you guys start thinking about this in terms of the computer science exam, they will present you with code and they'll talk about it being some type of loop and some type of sort. You have two options at that point. You can trace their code and go through a trace. They might say, what is the status of the list after 5 passes? Something like that. Or, if you recognize the code as a particular sort, you can just apply the algorithm. It's a lot easier to imagine the dancers than it is to go through and do a trace. A trace requires the table, keeping track of variables. I know you guys love doing traces, but that's a lot to keep track of. If you just know the algorithm, that makes that a lot easier. You can visualize it. The key is recognizing the code that they give you as the particular algorithm. In other words, you have to be able to give yourself the mom explanation of the code. Just like we did before, where we had a code or looked very complicated, we could give a trace and explain it, or we could just say, we're going to print out the highest value that you give us. That's pretty easy then to answer a question, what does this code do? And to say, what will be the final result. If you know what the code does, you could then take a list and say, oh, where's the highest value? Okay, that's what it is. So it's going to print out the highest value. It's going to print out this number. So the same type of thing will apply here. If you recognize what the code is and give that 30,000-foot view of what the code does, answering questions about it will be significantly easier as opposed to having to build a table trace. So that's why I've had you go through that exercise, giving the mom explanation. Because honestly, the mom explanation is for you. You need to be able to give the mom explanation to yourself. So you don't have to memorize code for this. They say that in big, bold letters for the AP exam. You do not have to memorize code. Well, they freaking lie, okay? You don't have to memorize the exact code, but you have to know the code for an insertion sort. You have to know what it looks like. And you could try to go through and figure that out every time and do the exercise that we did, where we say, all right, is it going to be a for loop and then a while loop, or then a while loop and then a for loop, and how's that going to work? You could do that every time, but it takes a lot of time. Yes, you could figure that out. So don't, because it's not the time that you have on the AP exam to do that. You need to memorize the structure for these loops. Yes, we can talk about it. Yes, we can learn how it makes sense that that's the structure. But at a certain point, you're going to have to sit down and memorize that the insertion sort code is going to be a for loop and then a while loop. And that's really it. Memorize there's a for loop and then a while loop, and then you're good. So here's another view of the insertion sort. This is a little animation here. And we can see as we go down the list, the red box is keeping track of the index of where we are. And it's putting each value into the proper spot. So there's two actions going on here. One is it's traveling down the list. The other one is insert into the correct spot. We actually did an algorithm in the last lesson where I said, how do you insert an item into a list? So the code that you used for inserting an item into a list is embedded inside of this insertion sort. So you're going to go through and just picking items from the back end of the list and insert it into the proper spot using that insertion algorithm we came up with the other day. You just don't know where that proper spot is. You got to find where that proper spot is. And you can see as we go through, the last value gets inserted into the list properly. So here is the pseudo algorithm here. We're going to loop from j equals 1 to the elements of the length minus 1 inclusive. So it's a for loop. It's indexed. And each pass moves the item at index j to its proper position in element 0. So to do that, we have to create a temporary variable to remember what was there, just to hold the value, and create a vacant element at index j, and then loop until the proper position is ascending order. Each inner loop iteration move the vacant element one position lower in the array, copy the temp into the... Wow, that's a lot. Again, this is a little bit higher level pseudocode than I would start with. I would start with just words, explaining what it was, going back to this and saying, what is it doing? In your own words. Goes through the list, one element at a time, takes the value and inserts it into its proper position. And then here we look at the actual Java code. This is the algorithm that the AP exam uses. It's exactly what we expected it to be, a for loop and then a while loop. So if you're recognizing that it's a for loop and then a while loop on the inside, this is a big clue that it's an insertion sort. Do you have to trace this once you know it's an insertion sort? No, because you know how the algorithm works. Could we trace this? Sure, that's fine. Will we trace it? More than likely. But that's just to understand how this code works and kind of really drive it in. But you should not be memorizing the code. You should be recognizing the code. There's a difference there. I don't need you to reproduce this line for line, statement for statement. I need you to be able to look at this and say, oh, that's a for loop with a while loop inside. I'm going to bet that's an insertion sort. And you'll see they have very distinct characteristics for each of these, for the ones that are on the AP exam. It'll be really clear which is which. Something that you can memorize pretty readily. So that's about it for today's lesson. We're going to continue with this. Like I said, this is a very hefty lesson because of all the different algorithms that are in it with this next time. Okay?